go 2, then 3, then 6, and then 11. I want you guys to ponder why he did that. Try plugging those in. Maybe you thought of it yourself, and maybe you didn't. Oh. But I love the 2, 3, 6, and 11. But
oh. Okay, yeah, you can. Because it's
oh, you're saying both, like number 1, 2.
It's in.
Try plugging in. Do you see why Andrew chose those? Now I'm going to ask Andrew advice real quick. Andrew.
Yeah.
Oh, also, you can do either one. Did you use the same ones for the second table?
No.
Oh, okay. Just a heads up for those of you still working on the first table. Don't use the same ones for the second table, or your life is gonna. Well, it'll be nice for like 1 point, and then it's gonna go sad. Remember, these radical functions that are being shifted and transformed. You gotta think about which x's to use. All right, Jonathan. Okay, so you already finished the first table?
Yeah.
Perfect. If you finish the points, we should be graphing those points.
Oh.
If you finish the points, we should be graphing those points. And then, once you have those points graphed, remember, they also are asking you to think about domain and range. If you take those points and if you graph those points, you're also trying to think about domain and range. And guys, this is what basically homework was on over the weekend that we're going to be grading in just 1 second. Were you able to make nice tables? Wait, hold on. This was only the end of homework, right? As far as the tables and the graphs, the rest of it, you guys were just filling in information. Only was the end of homework. Lots and lots of, well, there were only 2 graphs. Can I show you guys as you're working real fast, though, the back of this worksheet? What do you see? Okay, remember 10.1a, there were only 2 on the back. How many are on the back now? So you have a few more in homework tonight. You have a few more graphs, which is why we're practicing this, okay? You have a few more graphs, and I gave them to you on this paper, so you can use this as your graph paper tonight. I'm going to write that homework up so you guys can get it on your worksheet. All right, a couple more seconds before we go over the answers. Do the best you can to get points from the tables and the points to get graphs. And from the graphs to try to remind yourself what is domain and what is range. And how do you find it? All right, people that are super distracted this morning, let's go ahead and get focused in. For those of you that are done, you can write down the homework. It's right back here on the backboard. And it's time for all the talking and the collaborating to cease. So you've had a few moments to try to check in with each other and even ask each other questions, but now it's time to focus. A lot of you guys have on your desk, I can see, Jeremy, great job, 10.1a and 10.1b, because if we're trying to answer the domain and range question, Jeremy's able to be reviewing what he talked about, what he wrote down about how to find domain, how to find range. It's a great idea to be able to look at both. But that's also a good reminder that tomorrow, we're done with 10.1 as of today. Tomorrow, these are the 2 worksheets I'm grading, 10.1a, 10.1b. And 10.1a, 10.1b homework. But didn't you guys also do that chapter 10 intro worksheet, the one that we busted out in class, most of us? Totally need to give you guys points on that one tomorrow also. So we're going to grade 3 worksheets, 10.1 intro, A and B, and then homework, A and B. We'll get you guys a lot of points tomorrow, so hopefully you have those ready because you guys have been tracking pretty well. But today, for some reason, we're a bit distracted, so don't get lost on me today, okay? One more time, what's on the back of this worksheet for those of you that weren't paying attention a second ago? The 6 graphs and tables to use on homework. Wait, 1, 2, 3, 4, 5, 6. Literally. You can do it all right here. Anyway, homework's on the backboard. Write it down if you haven't yet. It's right back there. And I'm going to go ahead and fill in these tables and see if you guys got it right. When you plugged in 2, you guys should have gotten -0. Wait. Let's focus. -0. Isn't that just 0?
Yeah.
Oh, okay, no big deal. But when you plugged in 3, you would have gotten negative square root of 3 minus 2, which is negative square root of 1, which is negative. Did you guys get -1?
Wow, that's crazy. I did, and then she was.
No, I know. I said 1.
No,
I said
no,
1.
you said
No, I said 1.
Let's see.
Okay, is the square root of 1 1? Yes, but what was on the outside?
Yeah.
Whoops. Okay. Why did Andrew use 6? You guys figure it out? When you plug in 6, what do you get in that square root? And then you end up with -2. Good.
I was right.
And then why 11? Because what's 11 minus 2? Well, it's 9, and 9 square root is 3. Good. So did you guys go ahead and get your graph of 2 being at 0, 3 being at -1, 6 being at -2, and 11, which is that very last box, being at -3. And did you see your swoop going down? All right. Do we at least understand it now?
Yeah.
Okay. However, don't we have to be thinking about, for domain and range, x and where x is headed, and y and where y is headed? If you guys are looking at your worksheets from 10.1a, x is either greater than or equal to or less than or equal to, depending on how far left and how far right. The x's, are the x's going to the right, going higher, or going to the left, going lower? Look at the arrow. Which way are the x's going? To the right or to the left? To the right. That means higher, or above, or greater than or equal to. But we have to think about it. We're giving ourselves a range. We have to think about how low we can go. Someone asked me a question last week. They're like, wait a minute, if this is going higher, then why are we using a low number? And I use the example of someone who's like needing to get a job to maybe like support their family. Okay? So let's say like the breadwinner of your home, whoever that is, like a mom or a dad or a grandma or whoever is, probably more like a grandpa, whoever is like earning money for your home. Okay? Maybe an older sibling. Does your home have certain costs or bills that need to be paid every month? Yeah. Like maybe like rent or a mortgage payment, food. Is there, in most of your parents or your guardians, whoever's looking out for you, is there some sort of number in their head probably about like the minimum they need to make? Yeah, probably, right? The minimum they need to pay the bills every month. So what are they hoping they make in their job? Something higher than that, true? But they need to have that minimum in their head, as in like we can't go below that. That's kind of what's going on here. What can x not go below? What's the lowest x can go? In this graph, what's the lowest x can go? Because what happened if we plugged in 1 or if we plugged in 0? What kind of numbers were we going to get? Negative, and negatives are not allowed. So therefore, we have to think about the lowest. We have to think about that 2 and say, okay, we can go above that. That's totally fine, but the lowest we can go is 2. If we try to go any lower than 2, like 1.9 or 1.5 or 1 or 0, if we go any lower than 2, it's illegal. So we're looking at the lowest, even though x can go above that. Now hold on, with y, with my how high, how low, why is the inequality switched? X is greater than or equal to, saying x can be above or equal to 2, and that's it. Why is the y's lower than or equal to? What's the graph doing?
See how going down.
It's not going up this time, it's going down. Remember the x's are how far left, how far right. We wrote that clue down. The y's are how high or how low. The y's are going down. The heights are going down. Since it's going down, I say below. So it's going down, so below. What's the highest the y's can go? No. Those are the x's. Yeah, the x's can go to 2. But how high can the y's go? No, it can't go to 9. It's not going way up there. Does it go to 1? Okay, it goes to 0, right? Good. Good. You have to think about what's going on. Andrew, you're a little bit distracted. Let's get that phone going. So we have x being above or equal to 2, x being able to go to the right from 2, and y being able to go below 0. And that's it. Y can't go above 0, and x can't go to the left of 2. Now, this table I asked you guys to try to plug in. And when you tried to plug in, it might have been a lot harder, because maybe, I don't know if anyone in the class, did anyone put 1/2? That was a hard one. And then I would have put 2, and then I would have put, it gets a little bit nasty after that. But I think I would have done 9/2. Can we figure out how I figured that out? Do you remember, for good old-fashioned square root of x, the basic x's, and some of you were trying to remember it, are 0, 1, 4, and 9. Those are the easy ones to plug in. Root 0, I know. Root 1, I know. Root 4, I know. No, root 9, I know. When I saw this -2, some of you eventually figured out just add 2 to everybody. 0 plus 2, 1 plus 2, 4 plus 2, 9 plus 2. But this one's a little bit harder. What do I do with... Oh, I double them all. 0, 2, 8, 18. But if you try to plug that in to square roots, what did I do instead? I didn't double them. What did I do? I didn't add. I divided it. Wait, that's backwards what? Oh. Aren't we already supposed to be thinking opposite when we're inside? Opposite of subtraction is addition. Opposite of subtraction was addition. What's opposite of multiplication? Oh, it works the same way. Huh. Has anyone tried plugging in to see if these are actually good or not? If you plug in 0, what's 2 times 0? 0 plus 7. Okay, careful. Hold on. In our chapter 10 intro worksheet, what were we supposed to do first? Add or square root? Good. What's the square root of 0? Plus 7? Okay. Now I'm going to plug in the 1/2. So when I take the square root of, wait a minute, what's 2 times 1/2? Or what's 2 over 2?
1.
Oh. So what's the square root of 1 plus 7? 8, right? Hey, this is getting us nice numbers. Did any of you guys try plugging in other things and the numbers weren't nice? Hey, when you plug in 2, what's 2 times 2? What do I do first? Yeah, but what am I adding 7 to? Nope. Square root of 4 is 2. What's 2 plus 7? Now this last one would be really, really confusing as to where on earth I pulled that number out of if you didn't realize that I just divided everything by 2. And if I plug in 9/2, 2 times 9/2, if you guys haven't been seeing all this work, let me show. 2 times 9 over 2, the 2's go away. I just get square root of 9, and what's the square root of 9? And what's 3 plus 7? So I have 0 being up here at 7. I have 1/2, which is, I mean, that's not even a whole tick mark over, being up here at 8. I have 2 being up here at 9. And then what's 9/2? If I was to put that on a graph. 1/2 is 0.5, and 9/2 is 4.5. Good. So 4.5, kind of in between 4 and 5, that needs to go up to 10. Do I still have a swoop? Yeah, I do. Just a little bit harder to get. But guys, can you help me out with, I'm going to help out a little bit. I'm going to put x is greater than or equal to, y is greater than or equal to. I want you to think about why I'm putting them both as greater than or equal to. I'm saying x's and y's are going higher. But how high? Well, I don't need to answer the how high question. I need to answer the how low question. How low can x go? Think about tick marks. How low can x go? Look at your x-axis. He would have one. All of these, 0. I don't have any points to the left of 0. So 0. Remember the x's are how left to how right. So how left does it go? 0 has a point, but -1 doesn't, -2 doesn't, -3 doesn't. 0 is how low the x-axis or the x's can go.
What about the y's?
How low can the y's go? Yep. So for those of you guys that have your 10.1a worksheet out, are there any extra things that you need to write down in that worksheet to help you out? Because domain and range was still a little dicey today. Domain and range was still a little scary. Has anything made sense where it didn't before as to how we know greater than or how we know less than? Or how we know 2 or how we know 0? Are there any hints that you need to write in that worksheet? Because remember, we kind of tried the other day to write it down. And I'm going to show you what I have written down just in case you didn't put anything. For domain, remember I said x is allowed. And technically we could have done this with the problem that you just saw. Because didn't we, for one of them, didn't we have x minus 2 underneath the radicand? That's where homework started. And you could have added 2 to the other side. You could have used this trick. We didn't today. We just kind of looked at the graphs. But guys, did your domain end up being x greater than or equal to 2? Mm-hmm. How about the other one? The other one, what was underneath the radical? Wasn't the thing underneath the radical 2x? What happens if we divide by 2 and divide by 2? Did the other domain end up being 0? Yeah. So remember, we can use this little trick. We didn't today because we had graphs, but we can use this trick to solve. But if you're looking at graphs, you might also want to write down for yourself that you want to think about how left does it go or how right does it go. Looking at those values on the x-axis. And then for the range, we had some hints too. The range, remember we talked about whether the y is going up, greater than or equal to, or going down, less than or equal to. And then if it's going up, we ask ourselves, what's the lowest? And that's what goes in the box. And for the highest, what's the highest? And that goes in the box as far as what y is greater than or equal to, or less than or equal to, what number should go there. So remember, we're plugging in the lowest or the highest value. And that's exactly what we just did. We looked at the graph and we said, okay, hey, this one is swooping, oh, there we go. This one is going below, so less than or equal to. And what's that highest? And it was 0. And this one, it was going above, so we said, what's that lowest? And it was 7. All right, kiddos, you do have some graphs to do tonight for homework on the back, but don't you guys have a couple other things that are on that worksheet for you guys to think about? Yeah. Let's go ahead and peek at what's right next to the warm-up, okay? Let's peek at what's right next to the warm-up. Do you guys have a little bit of space there like I do? Yeah. Okay. We need to, well, hold on, pause. Let's figure out why we're doing this. Can you guys read the directions of the examples below? How many do we have? Like 4? Mm-hmm. It's just graphs. No big deal. Like, why do we have to talk about anything else? Read the directions. What does it say? In exercises 1 through 4. Okay, keep going. So that's what we just reviewed. And then, compare the graphs. Ready? This whole table is how to, ready? Compare. This table is going to tell us how to compare. If I were you, hey, write this down because you have to compare in homework. And when we do these examples, we're going to be comparing. We're going to graph first. That's the first step. We're going to graph, and that's why we reviewed it. But we're not just doing domain and range in homework tonight. We're doing this comparing step. So how to compare. Oops, that's not what. Computer had some issues. We move that back to where it's supposed to go. There we go. How to compare. If homework tells us to compare, this table is going to help us. Ready? If I was comparing either of these with, wait, what are we supposed to be comparing to? The directions tell us, right? Compare to what? How to compare to, don't look at me, read the directions. Just fill in the blank. Compare to
To the graph of.
Yeah, to the graph of who or what? Oh, f of x. Okay, they name it the snazzy way, not the y equals way. That's fine. To f of x, sorry, I was summarizing the directions. F of x equals? Square root? Okay, yeah, square root of x, radical x. Cool. Oh, and radical x is the guy whose graph I really like. Like, radical x is the guy who has, like, the 0 and the 1, 4, 9. Okay. The really cool thing is I've totally been giving you guys these words without actually writing them down. Because we were, just a second ago, talking about this guy. Now, he had a negative on the outside, but that's okay. If we see x being subtracting 2 or x being adding 2, what's the hint that I gave up here about whenever we see some adding or subtracting going on the inside? First, it's going to be what kind of change? Stretch, shrink, shift. Yeah. If we see addition or subtraction, it's going to be a shift. Hey, is that what that says? Shifts left or right. The snazzy word is translation. Okay, cool, whatever. We're going to be shifting, and then what do I tell you to think about whenever it's on the inside? Think opposite. So what we want to put for ourselves right here on horizontal translation is that little clue I keep telling you. Think opposite. Which means, if I were to compare after graphing, if I was to make sure that my graph was right, I should be able to look at the equation of this guy, and my comparing language would say that this guy shifts square root of x to the right 2 units. Now, we're not going to write all these words for every single one. I'm just writing it out the first couple times so that you guys see what I'm doing. How does it compare? Well, it should take the exact same graph and shift it 2 units right. How do I know that? Well, it says a minus, and whenever I see minus, I think plus. And adding on the x-axis is moving to the right. So what do you guys think is going to happen for the next one? Yeah. If I needed to compare, and if I needed to write that language, I would say that this one is going to shift this guy. Can I just shorten some of this?
Yeah.
Can I just say left 3 units? Is that cool?
Yeah.
Take out some of the to the blah, blah, blah. If you want to be super snazzy and super abbreviated, you could technically just say left. I don't mind. Now, if you want to use the really, really, really official language, you would use this word if there's been a horizontal translation. You could use that snazzy language. It's not bad. You can also just use shift. And the right or left is horizontal movement. But think opposite. Think opposite. If there's subtracting, I'm going right. If there's adding, I'm going left. Now, the nice thing is for this guy, you don't have to think opposite. You don't have to think opposite. That's only when you're on the inside. So this one, I'm still going to be shifting. But guys, if this is a vertical translation, which way am I shifting if I add 7 on the outside? Yep, I'm going up. Which way am I shifting if there's a minus 1 on the outside? Yeah. And here's the really cool thing about being able to look at an equation and know what's supposed to have happened. You can then double check your table and your graph and you can know whether or not you were right. They should match up. You should see that little swoop having gone up 7 or having gone down 1. You should have seen that little swoop going right 2 or left 3. So it gives you like a way of double checking. Your graph can double check your words and your words can double check your graph. Now these next ones get a little weird. Okay, so hang in there. We should be getting down this language because we're going to have to use it when we go to do examples. Now we have flips. So we have 2 different types of flips. And you guys did a pretty good job, I think, earlier this year. We had flips of, I think, quadratics. But we have a flip that's going to happen, wait a minute, on the inside and on the outside. On the inside, remember the guys inside, in and out? They're going back and forth. They're moving horizontally, right and left. The guys outside are moving up and down. We can still use that. Just this way is a little bit weird. Because if you're thinking of x, y axes, remember this is your x and this is your y. If you want to flip side to side, who are you flipping over? You want to do a horizontal flip. Who are you going over, though?
X.
Really?
Yeah.
I think you're jumping over the y, aren't you?
Yeah.
If you're flipping right, left, aren't you jumping over that y-axis? So that's going to be that inside, that horizontal. It's going to look really weird, but we're going to be flipping over the y. Whereas this one is going to be flipping, or the snazzy word would be reflecting over the x. It's a little bit weird because it sounds like we're saying the opposite, but no, if it's on the inside, we're going to be flipping what's right is left and what's left is right. So that's across the y. If it's on the outside, what's up is down, what's down is up. That's going to be across the x or over the x. Okay? Okay. Ready? Can you guys see what I'm writing and see if it makes sense based on what we just saw in that example to start off class? Whoa, whoa, whoa. What did I do to the numbers? Hold on. The 3 turned into a what? A 1/3. And the 1/2 turned into a what? Remember how just a second ago we had a 2x and I had to cut everybody in half? That's like this. A 3x would cut it in thirds. A 4x would cut it in fourths. If we have a whole number under there, we're dividing by it. And if we have a fraction, we're multiplying by it. It's weird, but once again, remember, we're thinking opposite. Whenever we're on the inside, we're thinking opposite. So if I were you, I would write that clue one more time right here. If I were you, I would write that clue one more time right down here. And if you guys notice, isn't there something similar about when the opposites happen? The opposites always happen with the horizontal. The opposites always happen when it's on the inside. But the nice thing is, if the insides are opposite, the outsides are normal. The insides are opposite, the outsides are normal. Which means if I see it 4 times on the outside, I'm going to stretch by 4. And I'm going to shrink by 1/5. You guys need to kind of realize what kind of shrinking and stretching. Horizontal shrinking is, remember, you're on the right, you're on the left, and you're squishing it in. Or horizontally, like a rubber band, right, left, you're pulling out. Vertical, up, down, you'd be shrinking. Or up, down, you'd be stretching. So you have to think about the difference between where or how the stretch or the shrink is happening. But anyway, this is all just comparing language, guys. We're going to use this comparing language for 1 and 2 and 3 and 4. Maybe we'll do the graphs and the tables, but maybe we'll just do the comparing language, because that's what's new. So I want you guys to look at number 1, okay? I want you to look at the equation, and I want you to try to match up. Ooh, shrink. What kind of shrink?
By 1/3.
Yeah, but is it a horizontal or is it a vertical?
Vertical.
You guys are rocking it. Let's go. Let's fill it in, yeah? How do we compare? We can say that it's a vertical. You guys fit it in the category? Shrink by 1/3. It's perfect. That's exactly right. Now, for those of you guys that are filling it in, did you find it in the table as to how we made that conclusion? There was a 1/3, and it was on the outside, which made you guys hopefully look at the very last row. Because only in the very last row was there multiplication on the outside. And then why was it not a stretch? Because it was a smaller number. So then, how about number 2? Shift, not down. Careful. Where is the subtraction going? Is it happening on the inside or the outside? The inside. Okay, hold on. Look, on the inside, is that up, down, or is that right, left?
Right.
Okay, and it's a minus, which means good. If you want to make it super snazzy, I'll show you how to do that in a second, but you could also just have said shift right.
1.
You see it?
I see it.
Did you see it in the table about how to find it?
Yes.
Shift right 1. Now, the snazzy way of saying it would have been a horizontal translation. right 1. That's if you want to put like a really long, drawn out, full, kind of like a mathematical sentence with lots of snazzy vocabulary. But yeah, shift right 1 or horizontal translation right 1. Now hold on. How could this help our tables? Because we just had a little bit of issue with our tables a second ago, right? Like, okay, how could this help our tables? Guys, remember? Hey, can you put this on your worksheet? Oh, no. Sorry, I want to make a table. Can we remind ourselves really quickly of the good old-fashioned basic table for square root of x? What are those great, just throw them in, we'll know the square roots. Which numbers are those? 0, 1, not 2, 4, and 9. Okay, those are the ones that we love. So what am I going to do if I need to shift everybody to the right one? What's my first one going to be?
0.
No, shift to the right one. Add 1. Does that make sense? Add 1. He has to shift to the right one. Oh, had to. Add 1. What's the next one going to be?
4. 3. 0.
Hold on. If I'm shifting to the right one, I'm adding 1 to my x's.
3.
So Alexis is trying to help you guys out. 5. Add 1. Add 1. Add 1. Got it. Those will give you the perfect numbers that will come out that you can graph. But can we talk about this guy? If I'm vertically shrinking, are those changing my x's, my right-left guys, or my y's, my up-down guys? What does this change? Yeah, this changes my y's. And here's the nice thing. If you only have changes happening to your y's, guess what you get to do with your x's? Keep them the same. When you plug in, this shrink is going to happen. When you plug in, I'm going to take the square roots and multiply by 1/3. I don't have to change my table at all. I can keep it as the nice 0, 1, 4, 9 values of my, what we call our parent function. This guy's the parent, these are the kids. Is one way of thinking about it. Aww, little kid functions. Anyway, but they're all going to change a little bit based on just their characteristics. So anyway, shifting right, let's add 1 to all of those x's. But if we have like a vertical transformation, we don't have to change our table at all. Just go for the 0, 1, 4, 9. We have 2 more though, don't we? Which of these is going to have to change our table? Number 3 or 4? I'm giving you a hint, it's only 1.
3.
Which one is changing x's and which one is changing y's? 3 is changing x's. Can you guys look at your table? Doesn't 3 change it horizontally?
Yeah.
Right? Now, hold on. Find me the language. Look at the table. Find me the language. If I have a multiplication. Yeah, okay. So I have a shrink by 1/2, because on the inside it's opposite. But do you guys realize there's actually something else going on? There are 2 things going on. A flip across what though? Or over what? Yeah. I'm thinking my head real quick. Because there's not just a 2 being multiplied, so that makes a shrink by 1/2, but there was also a negative. Now, if we take that parent function, again, that table for the parent function, you guys just told me 0, 1, 4, 9. What am I going to do to those? Look at one up. What's going to do in number 2? It's going to be kind of similar here. Look at what I did in number 2. This one is so similar. It's a little bit different. What do you guys think the first one's going to be? But I can tell you this one's going to be negative 1/2. If you look at the warm-up, did you look at the warm-up, number 2? There was a 2 underneath. And I asked for the first one, and Andrew said 1/2, and I was like, well, this one is negative 1/2. What do you think this one's going to be? Yeah, 0. How about this one? Negative 2. And how about this one? Perfect. I have to cut in half because of how it's changing. And I'm going to multiply by a negative, just giving you hints for how to set up the tables to make it nice. Remember, our goal is to have those nice points come out, because there's so many decimals. Ugh. We want the nice points, which is why we're so strategic in our table. And the nice thing by this guy, or about this guy, is that, guys, I can leave it 0, 1, 4, 9, because the transformation is what we call all these like changes. Isn't happening to the x's, it's happening to the y's, because it's not inside, it's outside. Check it in your table. So what's changed? Ooh, we're putting it in a snazzy way. Good. Vertical. Translation. I'd say up, just to give it a direction. Up 6, or up 6 units. But how could you do this in a short, sweet, like colloquial way? Shift up 6. And the nice thing is, you don't have to change the x's. When you go to plug in 0, plug in 1, plug in 4, plug in 9, what's going to happen? You're going to add 6 to them all. So it's just going to happen. It's just going to happen. Now, guys, check it. Do you have to write domains and ranges in all of homework tonight? I don't think so. I don't think so. In homework over the weekend, did you have to talk about domains? Yeah, that was the worksheet. Ooh, you got to do some matching. Those are supposed to be kind of easy. And you had 2 graphing ones. Now, check out tonight's homework. Hold on. Oh, check it. I did give you 22 and 24. I gave you 2 more, like the end of homework over the weekend with graphing and range. But then, do you see this comparing word come for the rest of homework?
Yeah.
Then we're going to use that comparing. So please, guys, have this worksheet closed because you were using the worksheet to know how to show the wording. And tomorrow, we're going to grade the evens on all of homework. Numbers 5 through, where are we going? 33, I think? Here, 5 through 33. But you only have to do a few homework problems. Let me just have this up here on the screen to take a picture if you guys haven't gotten it from the side yet. And Kayla, you have a question. I'll have it at my desk. Just come to me as soon as you guys leave. Oh, are we after? We're after. Get out of here. Thank you so much for waiting, guys.